Good to see everyone. Who was here last year, actually, in the same exact room? Okay, a few hands. Okay, a lot of hands. Yeah. Okay, I'm on time this year. I promise. I'm here. And yeah, I'm here to talk Llama. And actually, I think last year I talked really narrowly about Llama, really centered on the models. But I'm actually today I want to talk a lot more about the things around Llama and kind of the full stack that we're building, and some of the PyTorch components and kind of everything, this almost like an operating system that it's started to become, which is really cool. So for those who don't know me, the logos are a little hard to see. I'm Joe Spisak. I'm at Meta. I've spent a lot of time in kind of the open source and AI space, more than 10 years now, I guess, in PyTorch and Llama and building research in FAIR and other places. I also angel invest and advise some of the companies like Lightning and Anthropic and a few others. Enough about me. Llama, who uses Llama? Who plays with Llama models? Hopefully every hand in the room. Okay, cool. It's been kind of crazy how the adoption has just continued I mean, the growth has been incredible. I think we were showing kind of the Hugging Face downloads here. I mean, over 400 million. Every time I ping Omar at Hugging Face, it's like another 10, 20 million downloads. The derivatives are coming fast and furious, over 65,000. So people are using Llama, they're building on it, and they're putting their models out there. It's been crazy. We've had a number of partners. Every time we launch, we want models to be able to get as close to users as possible. So we work with everyone who from AWS to IBM and Snowflake and everyone basically to just really bring Llama models and our technology as close to developers as possible, and it's pretty awesome. I think we usually launch with close to 30 partners on every release, which is a lot of work, but in the end, it's great for developers. We've also seen adoption and growth of actual usage. This is from some of our cloud provider partners. You can see just very much an up and to the right, classic graph. And there's really no sign of this slowing down, which is a lot of fun. But also we've seen cost drop a lot. So who's kind of observed the race to the bottom? Who's you can see OpenAI, in Google and all the prices. That's been good because we want this technology democratized. And you can kind of see, I think when we released the 405B, back in July, our friends at Fireworks actually released it $3 per million tokens blended. So you're getting a frontier scale model that you can fine tune and run it on whatever you want. And even deploy it, say, locally in your own data center or whatever, and for $3, which is really wild. I mean, it's incredibly cheap. So really kind of brought this technology to really anyone. So who knows the history of Llama? I think I gave a little bit of this last year in the talk. So Llama 1. So by the way, these are all things I've prompted on Meta AI. So if you want to go and prompt all this, you can go to meta.ai and do yourself. But actually, who actually knows the team who built Llama 1? Does anybody kind of know the history? A few hands. Okay, so it was actually the team in FAIR. So they're actually doing theorem proving. And by night, they're training large language models. And they released this Llama 1 back in February of 2023. And it was basically just scrape together compute that they could get allocated where possible. And then they went off and started Mistral, and the rest is history. They've done some really cool stuff with LLMs, and really the explosion came with Llama 2. That's where we had a commercial license, and this really allowed Llama to be brought into enterprise and kind of for actual commercial usage. And we saw on day one, explosion of people doing further fine tuning of the models and releasing chatbots and running these models in different environments and local personal agents, and it just kind of exploded from there. It also was the start of, get my click here, the Meta AI story. So we have our own agent at scale called Meta AI, and if you go and you do search on any of the family of apps, you're using Meta AI. And that's actually powered by Llama. So we're probably the only company that builds something that is used by millions, tens of millions, hundreds of millions of people, billions even, but also actually open sources the underlying technology that goes into it. Obviously, post-training and things are different between the models because we're tailoring the models for different applications. But the underlying technology is actually very similar and basically the same in a lot of cases in the case of the pre-trained model. So it's a pretty rare thing, which is really cool. And then Llama 3 came, which seems like an eternity ago, back in April. So we released, really I would say this was more of a pre-release, I would say. So who started using Llama 3? A few folks. So these were like, smaller context window, but like the reasoning ability and the overall like strength of the models improved significantly over Llama 2. We did an update to Meta AI at the same time, and it was a big jump in performance. If I get my clicker to work here. Then in Llama 3.1, that's when we really extended the context window to something that was more usable, like it was 128K. But most importantly, we released the 405B, which really, I would say, has been, the journey to release that was absolutely wild. And the impact has been felt. I mean, the amount of work happening in synthetic data and distillation, and the fact that you kind of have this frontier scale model that you can then fine tune and deploy in your environment. We've quantized it in FP8, and you can deploy it on a single H100, H100 node. So it really brought the power of, I would say, a true foundation model to everyone. It's a very big model, so not everyone can certainly use it, but it made it truly available to everyone. And so who caught the announcement last week? Anyone? So timing was actually pretty good for this talk. You'll get to learn a little bit more of the details of some of the things we released last week. So last week we released Llama 3.2, which was, again, I always say this for every release. It was a labor, thank you. It was a labor of love. These models are so freaking hard to get out to market. There's so much that goes into it, so much in the way of weekends and blood, sweat, tears, work with all the different partners, safety, red teaming, everything it takes to get them out. So this time we released vision models, along with some other models I'll talk about in a minute. So this is our first multimodal models out of Llama. And so we released an 11 and a 90B. And you can think of these very much as like analogs to our 8 and 70s. So basically, we have adapter weights, which I'll talk about in a second. But these models are essentially drop-in compatible, but they support both image input as well as text. And you can see here we use an image adapter weight, adapter approach. So and I'll talk about the training here in a second, but it will take an image prompt. It'll take a text prompt. It'll combine the modalities and then kind of give you a response. And I'll show you some of the use cases here in a minute. In terms of how we actually train these, so the LLM itself is actually a traditional text-only pre-training. So much like we do we do large-scale pre-training. We pre-train 405B and all of our other models like 8 and 70. The multimodal, we also pre-train that, and basically, that is then a separate set of weights. We then align them together, and I'll talk more about that in a second, how we generate the data. And then we do like traditional kind of RLHF to steer the model and align it, and how it responds to you, and how it takes in prompts, and how we want it to kind of look and feel as a model. In terms of like how we think about the data, so we use it like so. Again, like pre-training is unsupervised, right? It's a lot of images, a lot of text, obviously in the LLM. In SFT, we use some open data from academic data sets. We use some synthetic data, which I'll talk about here in a minute. And then we also we spend, unfortunately, a lot of money on annotations and human curated data, which is actually a lot of what really makes these models great, though. And so it's worth the money, I guess. So in pre-training, we use roughly around 6 billion image text pairs. That gives you basically a set of pre-trained adapter weights that then pair with the LLM or the kind of text-based weights. And then we have from there kind of 600 million that are like really high quality, that are really kind of curated, that we use in post-training. And so if you remember when we were talking about back in July, I think I forget which conference I was speaking like right after that, and we were talking about kind of synthetic data generation for 405B, and it was like the killer app, and it's for us it was like a game changer, because then we had a true foundation model that we can then use to develop smaller models. We can kind of use it to generate post-training data. It's really, really versatile. It becomes this kind of platform that you can use, and it really allows you to do a lot of different things. And so we don't, by the way, none of the, like some of this isn't released in public, so you'll just see that it's a large model, it's generating data. But you can imagine like taking a 405B class model and generating both an image and a question, doing things like, like prompt augmentation and like basically generating kind of augmented prompts and kind of prompt diversity. And then from there, kind of ranking, like, basically ranking them and figuring out like which is kind of going to give you basically the best. And this is, of course, based on like a reward model that we generate. And then ultimately you can see like these get scored based on the reward model. And then what comes out of that actually ends up in our SFT data. So basically this is what we end up using in our instruction tuning. So this allows you really to scale up data for post-training like in ways that you just couldn't do before. Like otherwise you're like spending essentially, a huge amount of money trying to get humans to annotate these things and figure out different prompts and generate, different types of variants and prompts. And it just becomes very, very cost prohibitive for most companies. This way we were actually able to scale it up. And the results are really cool. So some of the applications we've seen that are really interesting. So of course like visual kind of Q&A type tasks where you can kind of prompt an image and like in this case, like I should eat more salads, but like you can see I'm like prompting what the salad is and it's giving me a set of ingredients and it's pretty detailed and estimates the calorie count. You can see like in text understanding cases like who's read the Llama 3 paper, the herd of models, all 92 pages of it. No, it's a great paper. So, we can basically prompt and use it because it has a long context. Like you can actually put a lot of the paper in there and you can do in-context learning and then generate accurate responses. So you can see it goes and we prompted, said how many parameters and tokens, and it was actually right. So 405B was 15 trillion tokens. You can also do things like chart and diagram analysis, which is pretty interesting. Doesn't always get the reasoning right yet. I think we're still as a community trying to get our models our imaging models to reason correctly, but you can see it starts to give you, pretty detailed descriptions and even like analyses of what's happening in these graphs, and this is getting pretty useful. And then there's like these things like, this is a handwritten set of equations. If you can imagine, if you have a child doing homework or whatever, and you want to be able to check their work. And obviously this is pretty easy for most of us. Probably a lot of engineers in the room, but you can give it the image and ask it to solve it, and you can see it goes and kind of stepwise goes and solves the problem for you. And of course, we do a ton of benchmarks, so I won't belabor these. We were pretty happy, I think, with the benchmarks across different, both image as well as text. So one unique thing I'd say about this model is we did optimize the model really for both image and text. So we didn't want text performance to suffer because we knew people would still use this as a language model, and so text to text was really important to us because we ourselves see the usefulness of that. And then we added obviously the ability for it to reason on images as well. So the fact that it's kind of a one model drops in, you can use it for a variety of things, agents and multimodal agents and so on, is really powerful. So the other thing that this is super near and dear to my heart, I've been pushing on this for quite a while at Meta, is the small models. So who's played with the 1B and 3B? Anyone built like the mobile apps or like an Android app with it? Or okay, you got to go on GitHub. We built full apps in Android and iOS, and I have a demo at the end. I'll show you guys. But I was so amazed at the speed of these models. They're incredibly fast, especially the 1B. It's a really fast model. So we started to think about basically what would be useful for applications ourselves, like as Meta would like to use these models for, and then we started talking with the community, and I've been pushing on this for like well over I think a year now, and trying to like think through what we should build and what would be useful. And so we finally shipped these last week, and I couldn't be happier honestly on the performance of them. We've also used the 1B model, and we've actually pruned as well as quantized it and released that as a Llama guard. So you can actually use as a safety model. It's like 500 megs. Super cheap. We have it running on a mobile device as well. So it's actually an orchestrated safety model that's running on a phone along with the core LLM. It's pretty crazy, and it works really fast. So it's pretty impressive. So when we thought about these models, we actually were pretty prescriptive in like what use cases we were trying to think about. So it's really hard to build a 1B model that is like very general and that like has really strong reasoning, right? And that it's also great at coding and it's also great at math and all these things. And we just like looking at the use cases for like edge devices and like the experiences we were trying to drive, like we decided to really focus our post-training on a handful of things. So things like summarization and retrieval augmented generation, writing assistance, like I know it's not a very sexy application, but like prompt rewriting and like, and be able to like generate like augmented prompts, like not having to go like to the cloud round trip is really useful. Like it's not very exciting, but it's really useful for like developers and for like privacy and for applications. And so we really decided to just zero in and really focus on these like few applications and use cases in post-training. And we were like super happy with the results, to be honest. I'll show you some benchmarks here in a minute, but the way we got there is we actually took both a pruning and a distillation path. So again, going back to like we have this great foundation set of models, how do we leverage those to create something small that's also really performant and is strong as a model. So we started with pruning the 8 billion parameter model. So we pruned off a bunch of weights from it. We then started to distill logits from both the 8B and the 70B, as well as generated synthetic data from the 405B. And I have actually I had a better, more detailed chart, but it was kind of hard to read, so I kept it out of here. But you can kind of see what we did here. So in pre-training, so just like any other model, you kind of have the pre-training and post-training steps. And so in pre-training, we did knowledge distillation, which means we basically generated, logits based on next token probability from the 8B and 70B. And those basically waterfalled into, the 1B and 3B respectively. In post-training, this is actually where like things got really interesting, right? We generated synthetic data from the 405B that was really, really useful. We then trained in SFT on synthetic data for both the 1B and 3B, and that's where like having really, really high quality data from a foundation model is incredibly powerful, and that the results really show. And you can see, actually here's the results. So you can see like some of the areas where we really focused. So like BFCL and Nexus, if you don't know those are tool use benchmarks. So we really wanted these models to be strong at like agentic, local agentic applications. So you can see those numbers are kind of bolded there. The instruction following, so IF evals and instruction following benchmark, we're like well out punching or outscoring, I would say, larger models in some of these cases, like Route 67 versus say like the Phi is like a larger model and 3.8 versus a 3 billion. So you can see like some of the areas we really, really focused on kind of shine through in the evals. Now the evals only tell really part of the story. They're really academic benchmarks, but this kind of was it confirmed like a lot of what we thought. So switching gears a little bit, so we also released something last week called Llama Stack. So one of the things that we've learned over the last year or so is like Llama models are important, but they're also like one really like pretty big piece of the puzzle. But they're one piece of the puzzle, and there's a lot of other components that get orchestrated. And we kept hearing the same feedback over and over, like when you guys release models, stuff changes, like maybe the system prompt changes, or maybe your prompt format changes, or how you generate outputs for tool use, or JSON versus Python. We kind of heard a lot of feedback. And we also heard like from our partners in like cloud providers and platforms that they're trying to basically every time we release stuff, they have to go and integrate with things like LangChain and Llama Index and a lot of these projects and VLM and kind of those types of projects, and they're kind of tired of like doing that over and over again. So we decided to basically come up with a clean and kind of stable API. And what this actually provided, not only an API, but a CLI. So, as a developer, like having a CLI is really handy. I don't have the slides here. I gave a similar talk at Y Combinator like maybe about a month ago where I was talking about this, and it's like really handy to be able to like just be able to download the models with the CLI, be able to like inspect like what models are available, like what sizes, what context windows, like all that stuff, and then be able to like very easily start to deploy them or evaluate them or do these things all in like a nice CLI. And so you can kind of pip install this or use Conda, and then you kind of have this library of things that you can do with Llama models. So it very much like it incorporates Llama into like traditional like software development workflows, which is really nice. Let's see. So this thing called Llama Stack, so basically it has a few different components. It has this agentic system API, which basically has things like memory, which incorporates things like RAG. We also have things like Shield, so if you want to orchestrate multiple models for safety, that's like built in, and you can kind of do that on day one. And we think that's really important because like it's not just going to be one model. You're going to have a number of different things that are going to get orchestrated as a system, and you want to be able to kind of do that in an efficient way or not have to rewrite the code or re-implement that every time. Then there's also this model toolchain API piece, which includes, I'll talk about PyTorch and all the good stuff here in a minute, but how do I like plug into, projects like VLLM or TorchTune or Torch Titan, say I wanted to do like continual pre-training, on these models. What if I wanted to, like quantize a model, for example, and use like Torch AO or something like that. Like having kind of a consistent like API and workflow for that is actually pretty useful. And so what we've started to do, we actually released our first distribution, and we had a number of partners, and forgive me, but it's a little dark, I think, on the screen there, but you can kind of see some of our partners, like Dell and AWS and Grok and NVIDIA and folks, Llama and Together, Fireworks. These are the folks that we worked with as early partners. They've adopted Llama Stack, and they've started to build to the spec into our APIs and integrating with us. And what this means is like they're kind of like resilient to the next generation that we release, and they'll be kind of there on day one with us. And as features start to roll out, we have new features in Llama Stack. They'll be supporting those. So this is probably my favorite part of the talk. Both projects are near and dear to my heart, but I'll talk a little bit about PyTorch now. So when we think about some of the things that underpin a lot of the work here, if you look at all the way, from like the 1B to the 405B, the glue that in the foundational components to get all of this, like to achieve all of this, was PyTorch. So whether it was like how we distill the models, how we deploy them onto devices like ExecuTorch, whether we through pre-training or continual pre-training or fine-tuning, all of this was really PyTorch at the end of the day. So it really is kind of like, and it's not just Llama, obviously, like others like OpenAI use PyTorch and Anthropic and others. So it's become a foundational piece of like how generative AI is happening. So just a few of the cool libraries that I love that I think are foundational to how all this is happening. And I'll go through them one by one here, but like I'm kind of curious, like who's heard of TorchTune? Okay, cool, a few folks. So I helped build that project from the beginning, so I love that project. Torch Titan, who's like actually scaling LLMs here, like who uses FSDP or a few folks. Okay, cool. Torch Chat is a fairly new project actually for inference. Torch Compile, probably a few folks, yeah. So, kind of optimizes your code. And then ExecuTorch, which is, we're going to do another blog post here on ExecuTorch like pretty soon. But that is like the project that we're betting on for on-device. On-device has been, kind of this crazy mess in the software space for the longest time. And we're really excited about where ExecuTorch is going. So first off, fine-tuning. So TorchTune, we thought long and hard about, what we wanted to go build as far as, how you fine-tune libraries. What we actually found, let me just check my time here, good, is when people were taking like Llama models and they wanted to fine tune them, the heuristic people had was I go to Llama recipes and I grab the Jupyter notebook that a gentleman named Hamid over at Meta built and basically like copy and paste some code. So there wasn't like a really great like library that was out there. There wasn't really a great like clean experience. And so we decided to build TorchTune, and we decided to build this last year, and I think the reception's been really great. And so you can imagine like fine tuning using things like LoRa, QLoRa. Like basically it's a true library. It's not not really a framework. You can kind of plug in these capabilities to your workflow, and it's a very clean and well-maintained project. So if you're looking to fine tune a Llama model, this is probably a great place to start. if you are looking to, I mean, I don't know how many people are doing pre-training these days. Probably not that many at this scale. But continual pre-training, I think, I hear actually quite a few folks are trying to take models and do CPT. This is a great library, and it's actually, this is incredibly popular. So if you want to use FSDP or pipeline parallelism, basically this is a really nice composable library. It allows you to scale up things like continual pre-training using like low precision, like FP8. It actually has like support for like async checkpointing. This is like a lot of how we scale up models at Meta. We use Torch Titan. And so if you need to do that, you can kind of import it and use it on mainly NVIDIA GPUs is what we support today. If you need to run inference, there's obviously a number of projects. Torch Chat is a project that basically allows you to run across the board. You can kind of run it in local environments. You can kind of run on device, and it like seamlessly works with ExecuTorch. We have some like demos. We show how you can run like multi-node inference or distributed inference using 405B. So it's a super versatile library for inference as well. And then in terms of compiler, so one of the things that we focused on for PyTorch 2.0 when that came out was really the compiler. The compiler was like the big effort and big delta from like the 1.0 era to the 2.0 era. And so we've continued to push on compiler as a way to obviously drive more performance, but also like a more diverse hardware like universe around PyTorch. And you can see like some of the backends. Obviously, Torch Inductor is like is a native backend for PyTorch, but we also support like NVIDIA and Intel and a number of others. And you can also like incorporate things like Torch AO. So if you wanted to like quantize and then incorporate your like compilation passes, like that all works really nicely together. And then lastly, ExecuTorch. So this was kind of like the unsung hero, I would say, of like the Connect launch last week. We showed some really cool demos. They were in Mark's keynote as well as Chris Cox's keynote at the event. And ExecuTorch was the underpinning of all of our kind of mobile demos. And that, along with like Torch AO, quantizing, and then basically being able to run these models efficiently on, say, both iOS and Android devices. And we're not limited to those devices. We actually showed a mixed reality demo of a headset running the 1B model, which was really amazing. I don't think it ended up being public, but I think I can post the video at some point. But it was really cool that we built that demo in like I think 2 weeks. So really cool stuff. So I'm gonna run out of time, but I want to show you this really quick demo, which says it can't play the file for some reason. No, the demo gods. No, where are you? Let's see if I can get this to work. If it doesn't work, then I will just tell you how cool it is. What's that? There's a link?
There's a little arrow on the top. Do you see it?
Oh, yeah. Oh, you know what? I bet you it's because I'm not connected to the Wi-Fi. That's why. Let me see if I can. Let me see if the Marriott conference Wi-Fi is good.
There's a resummon Wi-Fi.
Is there? Okay. Is there a password? Yeah. Whose iPhone is this? I'm just kidding. Or whose DB, actually? I don't know. Let's see if I'm connected. No, I'm not connected. Weird. Yeah, it's not coming up, though, interestingly enough.
There's a hard line at the podium.
Whoever that is, I'm sorry. Is this Alexander's phone?
No, that's me.
Really?
The password is just for you.
Let's see if it works. I love you, man. Let's see if it really works. Oh, no. Where is it? Where is it? Oh, look at that. I'm streaming off your phone. Ah, you're my hero. Okay, so we're going to load a model. This is the 1B quantized to integer 4. And you can see we're just doing some basic prompting here. There's nothing special here. So like how to start a campfire. The trick here is like to check out like how fast this is generating. So one of the coolest things we had ARM speak at the conference last week, and you can see like I'm running almost over 42 tokens a second, just running on like a mainstream Android device, which is like wild. Feel how snappy that is. And ARM actually demoed, I think, 250 tokens a second, like pre-fill, and then something like 60 tokens a second generation. So if you think about it, this is a 1B model that's really coherent, that actually will do agentic stuff like on your phone. You hit almost 45 tokens a second there. So all of this, by the way, is like open source. It's on GitHub. You can get it. You can build the phone. You can build it on your phone, whatever. It's like free. The model's there. All the code is there. The app is there. So literally go get it and play with it, fine tune it, and build your own local agent on your phone. So, and that is it. Thank you so much, and thank you.
All right. Thank you, Joe. We have a few minutes for questions. Please raise your hands. I'll get the mic to you.
The 1B model is really impressive. Could you comment on the AI companion? Like we saw this new release from the Meta on the Ray-Ban glass. Is that what's the company going for, to develop more like a high intelligent AI companion with local device?
Yeah, I mean, I think the glasses have been super popular, the Ray-Ban Metas, and I don't know if it's like luck or if it's like just like really these like AI and kind of mixed reality coming together. Did you see the Orion demo? Like it was wild. You gotta definitely check that out. Mark did the demo in the keynote last week. And I think, yeah, I mean, I think these things are like coming together at like the right time. And like I said, we were running, I think it was on a Quest 3 Pro, we were running like the 1B model, and it was feeling, and basically playing around with mixed reality, like with multiple people seeing the same thing and being able to converse in different languages, and do generations and all that. And input images, because it was, you can have like we had different multimodal models on there along with our LLM. And I think this is where things are going. And I think because you want low latency, and you want privacy, and you want all these things, and you want it kind of, because obviously a round trip to the cloud if you're wearing a headset or your glasses, like I don't know if you've ever played with like some of the wearables, like the Humane Pin or whatever. The latency is really, really long, so you don't want that, right? Obviously, so.
I have another question regarding the post-training. Do you think synthetic data is 100% all we need? What's the percentage of synthetic data versus real data used in the post-training for Llama 3?
Sorry, how much was
The percentage of synthetic data versus real data. I don't think it's 100% synthetic data for post-training, right?
No, it wasn't. I don't know what the percentage offhand, maybe like, it was more than the curated, so probably more than half was probably synthetic, because it's that, like, you can scale up the synthetic data quite a bit more. Obviously, I'm paying a lot for the curated, like annotated human data. So. Cool.
Can you share with us what to expect in Llama 4 or Llama 5?
No. But I mean, we've teased some of this stuff. I think you can imagine where things are going in terms of modalities and languages. Oh, sorry, not speaking in the mic here. I mean, you saw like if you follow kind of meta AI and where that's going in terms of like, we showed voice and voice to voice last week. We're a global company with billions of people on our platform, so more languages, better reasoning. So I think that you can imagine that those are obvious directions we're going. We're obviously going to continue to push scale, because we have obviously a lot of compute and a lot of ambition, and we want to build the best models in the world. So yeah, Llama 4, Llama 5, they're going to be fun. So I can't give you any secrets away, but like stay with us. We're building some cool stuff. Yeah. Yeah.
So I think we all just listened to the OpenAI CPO talk about how they're going to be scaling up essentially inference time compute as well. They're going to be start scaling up inference time compute to get better performance. Can you talk a little bit about like Meta's approach here as well? If you guys are doing stuff there.
I mean, I can't comment really on what we're doing there. I can point you to like a couple of projects in the past though. Like, I feel like inference time compute and like tree search and RL, like inference time. Like this is, I mean, there's some work in the past we've done, like the diplomacy project, which is one of my projects that I helped work on, and I think that there's prior art there. I think the trick with that technology or that approach is like how do you generalize it, like in a way that like can be more broadly useful. With diplomacy, for example, it was pretty amazing what we did, but at the same time, it was like in the domain of like diplomacy was like really useful. But once you kind of got outside the domain, it was like very like you couldn't converse with the agent at all, right? It just would fall apart. So I think we have like a lot of those people are still around in Meta and they're working on these things. So we have experts in kind of all those areas. So you can imagine kind of some of the areas we're pushing on. So yeah.
Just building off of everyone else's questions, does Meta have plans to release a O1 equivalent where we can see the reasoning and the change of thoughts being exposed?
I can't comment on anything we haven't released. But I mean, reasoning is like an important area to push on because it is kind of like it's foundational to agents, and so we have an entire team that focuses on reasoning, and so we'll continue to push on that. So yeah.
Awesome, looking forward to it.
Cool.
Any other questions?
Yeah, just a quick question around the recent Malmo release. Have you all done any benchmarking or comparisons? I know that the timing was pretty tight with both of those models.
I actually haven't looked at those models. I know they. Oh, sorry. I mean, I saw the benchmarks, and I saw there's a lot of benchmarks that fly around. I honestly haven't had time to actually play with them. I think these are the AIT ones. Yeah. I mean, they look good on paper. I think we'll probably benchmark them and see what we can learn from them. Certainly. I mean, but yeah, there's like I know NVIDIA even like yesterday released a multimodal model as well, and like so yeah, it's good. They're coming out like crazy. It's awesome. So in my opinion, anyway, like the more the merrier. Like the more people and more companies release, I think it's a good thing. So, but yeah, we'll take a look at them. Sure. Cool. All right. Thank you.
All right. Thanks, Joe. Thanks everyone for joining.